talk about adding vectors a little bit more carefully. I've given you pretty much everything you really need to know. I just need to sort of focus it and make sure you get it. So, adding vectors on the same line. When two vectors are in the same direction, pretty easy to add them. Place them head to tail. Simply measure the total length. Or in other words, just add the two magnitudes together. What does this do? Ooh, 8. 6.
What is that equal? 14.
You can just take 8 and 6. Okay? How come? Because they're pointing in the same direction. You just add them together. If it was 8 and a minus 6, well then it would be 2, right? I see a few people writing, so I'll pause for a second. I ask again, because I don't want to have to give you the look when you ask me later. Does the order that the vectors are added matter?
No.
Yeah. 6, 8. What do you know? 14. The answer is? The order does not matter. Ooh, what if the vectors are not on the same line? I need this better here. I need to fix this. Place the vectors tip to tail and do what? Measure the resultant. Where is it? There it is. Oh, look at this. Bang. Oh, bang. Delay. How do you measure it?
With a ruler.
With a ruler. Get out a ruler. Where's the little twisty thing? There we go. Oh, you know what? This is a special ruler because it has a built-in protractor. Man, that's cool. I know. So you actually measure with a ruler 10 centimeters. You convert it by scale if you need to. Like if my scale was 1 centimeter equals, let's go, 5 kilometers per hour. Well then 10 centimeters must be 50. And what's my angle? Oh, my little protractor tells it to me. You'll have to get out of but mine, look at that. I think it says 31, actually, right? Okay, so that would be, what would that be now? Now that 31 is from?
East.
Again, it's east. It's not always east. Don't get into that idea just because I've done it east twice. Okay? Not always east. East, 31, north. What if, Mr. Bennett, what if I write north 59 east? Are you going to mark me wrong? No, they're the same thing. Okay, I got to have like about 5 answers on my page when I mark them. Okay, of course you're going to need an actual protractor. Where's the green thing? No, don't do that. Yeah, I think it is. But it must have something I can move. Oh, where is it? Oh, okay, it goes like that. $31. Okay? You're going to have to play a little bit with that in your own protractor. Now, I heard someone say Pythagoras. The resultant vector can be measured or calculated algebraically. Right? As we learned today, the word how do you pronounce that in Arabic? We all knew it was algebra, right? We could tell, right? Algebra or something like that. If the vectors are perpendicular. Now, on this test, at least 5 of you will have the note put on your test, not a right triangle. You can only add them by Pythagoras when it's a right triangle. And yet I say that and 5 or 6 of you will do the exact opposite. Don't do that. It has to be a right triangle before you can use Pythagoras. Okay? Well, now I've got 5 and 8 there. Good one. Six. 6 squared is 36. 8 squared is, oh, that's actually went so much better. 64. 36 and 64. 100. 10 kilometers, right? Everybody knows that? A squared equals B squared plus C squared, yeah? Does it matter? Well, I've got R squared. Is that okay?
No.
Of course it's okay. Does it have to be A squared equals B squared plus C squared, or could it be C squared equals A squared plus B squared? Of course, they're just names. Doesn't matter what you call them. Like, as long as the longest one is the one by itself, you're good. Do you guys remember how to do this part? It used to be grade 9 math. I don't know what it is. It's grade 10 math now? Okay, so opposite, do you know about sine, cosine, right? SOHCAHTOA? Right? So is it always going to be tangent? I quite often get that question. Tangent is opposite over adjacent. Am I always going to have an opposite and an adjacent?
No.
Sorry. How come? Because the hypotenuse is always going to be the result, the one that I just figured out. Right? You're always going to have, if it's perpendicular, you're always going to have an opposite and an adjacent. Always. Now, file that away for grade 12. Okay? Because what we're going to do eventually is we're going to learn how to take vectors and break them into what we call components. And this vector there in red is broken into the x and the y component. I'm just doing a little bit of foreshadowing for you, that's all. Okay? Anyway. So tangent theta. Where's my theta? Where's the angle that I'm measuring? Between the red line and what?
6.
The 6? This one here?
Yeah.
Or this one here?
That one.
When you say that one, I think you mean the second one.
Yeah.
You're absolutely right. You always have to measure from where? Where you started, where there's no arrowheads. So theta is equal to opposite over adjacent. Tan theta is opposite over adjacent. What's opposite?
6.
Whoops. 6. What's adjacent? Whoops.
I do that.
Got to fix that. Got to fix that. Tan theta then is, oh no, this is all going to be completely wrong, isn't it? Okay, so let's do this here. So how do you do this on your calculator? Do you remember? Now, some of you have what are called the reverse Polish calculators. Some of you have what's called the regular guy calculators. Are we good here, Ryan? Okay. So some of you are going to have to go second function tan bracket 6 divided by 8 bracket equals. And some of you are going to have to go 6 divided by 8 equals second function tan. It's up to you to know which way your calculator works. Whatever you need to do, you got to get yourself to an answer of, oh, that's a phone, that's not a calculator. 36.8? You know what, we should talk about that. 36.9 cubes. That sounds about right to me. That's going to be, again, I went with east again, didn't I? East, 36.9. North. Let's take a brief moment and talk about rounding. Actually, I should make sure that does everyone know how to operate the calculator? Like, make sure you know. It's pretty important. Has everyone tried it on their own calculator? Yeah? Everyone's good? Okay. You have to be in degrees. If your calculator is in radians, it's not going to work.
I see a little M in the corner.
And there's some sort of thing in the memory. I do also do calculator technical for parallel. You get something with that. Okay, everybody can get the 36.9. Let's talk about rounding just for a quick sec here. Because I haven't had this problem for a long, long time. I'm hoping that teacher is long since retired. Don't yell out. So think about it for a second, because you know what I'm going to ask you, right? Which one is correct? Hands up. 14.4. Overwhelming. 14.5, anyone? Ooh. 2 people said this. Yes, 14.4, sorry. Now, at one point, I actually knew of a teacher that was telling kids this, because I could locate them. I could say, I don't think you guys went to elementary school together. Am I correct? Yeah. I actually figured out which school it was happening. They were telling them, do this, make that a 5, 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 make that a 5. They were telling that. Complete and utter rubbish. Wrong. Now, before I go today, I need to make sure that everybody's mind, not just Joey's, is because I got something for you all about rounding. Don't let me forget. If I do it now, we'll never get off topic, okay? Or on topic. But no, because I know what will happen if I do it. So give me like 3 minutes. Somebody sit there, watch for like 3 minutes before the end of class, and I'll give it to you then. Because if I start now, it'll just... Okay, I'd like you to practice this one. Okay, here's a practice one for you. A man walks 3 kilometers north, then 1.5 kilometers east. What is his resultant displacement? I'm asking you to add those vectors together. Solve by scale drawing and Pythagoras. So get a ruler, get a protractor. Pardon me?
Right angle?
Yeah, it's north and east, so it's okay. Yeah. Okay? I'll wait for 5 minutes. Okay, let's... So I got to have a scale. So 1 centimeter equals, I'm guessing you went 1 kilometer, right? So 3 kilometers north. I actually have to draw this over here, right? Three kilometers north. I didn't put an arrowhead on it just so it's a little bit easier to see. By the way, you have to put the arrowhead. It's a half mark deduction if you don't.
Should we round the big degrees?
I'll wait till I get an answer and then I'll show you, okay? Okay, so I go 3 kilometers north, then I got to go east, right? So from here, I'm going to go east. Oh, that was a mistake. That was a big mistake. Okay, your ruler doesn't, of course, get bigger, but mine does, so that's going to be a problem. No, don't do that. One and a half to there. Okay, and then your resultant is from, there should be an arrowhead on this one here. Your resultant is from there to there. Is that what yours looks like? And then you would actually get your ruler out and you would actually measure that and you get your protractor out and you measure this angle in here. Let's do it by Pythagoras, okay? Obviously the by Pythagoras is a whole lot more accurate. So it's going to be, label this one R. We don't really have names for those, so we'll just say 3, 1.5. So then you'd write R squared is equal to 3 squared plus 1.5 squared. I just skip ahead to this step. Is this okay? If I just go 3 squared is 9, right? If you want, if it's kind of hard, you can go square root of 9 plus 1.5 squared is 2.25, I think. Am I right?
Yep. So
R equals the square root of 11.25, and I can't do that in my head, sorry.
3.4.
3 point what? 3.5, okay. 3.35. Now here's where I sometimes have the discussion about sig figs. My general rule is this, okay? I would like you to go one more decimal place than the one that is given. So I've got 0 here, I've got 1 here, so let's leave it as 3.35. Okay? If you write 3.4, I am not going to freak out. It's fine. I don't care about how accurate that is. I care about how you've done the process. Please keep in mind that at some point, somebody will care a whole lot about that. Okay? So don't say, well, my high school teacher didn't care about that. fine. Okay? But can you do this? This is what I would do. Okay? And then when you get to that point, then it's going to actually matter. Okay, so then I got an angle right here. I just write theta equals. Is that okay? Theta equals, does everybody know by what I mean by tan minus 1?
Yep.
Inverse tan, opposite over adjacent. So in this case here, opposite is 1.5. Opposite is 1.5. Adjacent is 3. So 1.5 over 3. And then I usually just write the answer. What'd you get for an angle, Ryan?
26.5.
26.5?
Yep. That rounded up.
Yeah, I'm quite comfortable with the angle just being 0.7. We don't need decimal. Again, the process is what counts. I'll look at yours. I'll take anything from 26.5 to 27. As long as you show me how you do it, that's what's important. Now, you still have to say what here? North 27 east. You still got to say that. Okay? Again, you can only do this Pythagoras stuff when what? It's a right triangle. I can't stress that enough. Okay, it must be a right triangle to do that. What you going to do when it's another angle and it's not a right triangle? Scale drawing. Scale drawing. Okay, you've got 6 minutes. It's real hard to do on a smartboard. It's one of the more challenging things I have to do. Actually, let's do this. Okay, so I've just drawn my, it was really hard, I have to draw my scale. What's this little line right here? It's just a reference line, that's all it is, okay? It's my line that shows where I'm measuring north to be. Okay? Then I had to draw a line, a vector that's 10 centimeters long, because my scale is 1 centimeter equals 1 kilometer. This angle in here has to be 30 degrees. Oh, I went, yeah, no, it's okay, because it's 60. Okay, if I bring in a protractor, it should be, degrees. I'm off by a little bit. That's okay. Okay. Now, did you realize that you sort of got to plan your picture out? Because it's quite easy to run off the paper, isn't it? Right? Pencil and eraser. The pencil's got two ends, the pointy part and the eraser part, and both of them are important. Use the eraser. Now I go west 15 north, so I actually have to go down a little bit here, don't I? No, you don't have that luxury. Okay, so from here I have to go west 15 north. Where do I draw my reference line? I'm going to do it in a slightly different color. Well, I'm going to do it in black first, I guess. From here I got to go west, right? Does it matter how long the reference line is? No, it's just a little reference line. I have to measure from that. 15 degrees north. Bring my protractor back in. Make it bigger. No, make it bigger. north. 10. 15 is right there, right? And I have to make it 8 centimeters long. Now, I wish it had a way of telling me how long that is without my ruler. How long does it have to be? 8. 15, 8 is 7, so a little bit too far, right to about there. Okay. All right, so now where's my result? From down here, switch to that, from down here to there, right? So what yours looks like? More or less? No? Okay. And then where do I measure? First of all, measure the length, which is this one here. Centimeters. Does it matter whether you measure from the start or the end? I get 11.5. Is that what you get?
I got 11.6.
If I say it's 11.5, then that means that you guys can be anywhere from 11.2 to 11.8, right? Are you in that range?
Yes.
If you've done it right, you're in that range. I give a little bit more leeway if we're adding more than 2 together. So 11.5, that's centimeters, so that means it's also kilometers. 11.5 kilometers. And what's my angle? Where do I measure from? Again, you have to measure from north or south or west. So I've got a north one right there, so I'm going to put my protractor right down there. And I measure my angle to be 13 degrees. So 11.5 kilometers at north 13 west. Hands up if you think you got it close enough.
What if we drew our triangle wrong?
What did you do wrong?
I did 15 western corners.
Then I would probably take off one. If everything else is good, you get 1 out of 3 like this. Okay, questions or I did it right? Did it right?
Oh, would 10 degrees be fine?
Pardon me?
10 degrees?
Yeah, 10 degrees is fine. Yeah, anywhere between plus or minus 3, so 10 to 16. Okay? You either get it within that range or it's completely wrong and it's pointing in a completely different direction. Okay, I'm going to stop yakking.
We needed to learn about the...
Oh, yeah. Okay, have I got time? Ooh, just barely. Just barely enough to blow your mind. Okay, Ryan's going to hand these out. What? Okay. These are some practice questions. Do not do subtraction. Do not do subtraction. There's 6 of them. On the back are the answers. On the back sheet, detailed drawing solutions. If all you can do is copy them out, do that. You will learn something by copying them out. Okay? Do those 5 tomorrow when I'm not here. Okay? By Monday, you got to have those 5 done. 6. Okay, the solutions are there. Okay.